Adrian, I think we are live.
Yeah, we are. Hello, everyone, and welcome to our webinar, NoSQL Showdown, a deep dive into DynamoDB versus MongoDB. My name is Adrian, and I will be your host for today's session. We are thrilled to have you here as we explore two of the most powerful NoSQL databases, DynamoDB and MongoDB. Today's session is brought to you by DBSync, a zero maintenance data replication and ELT platform. However, today's webinar is not about a specific product, but rather about gaining technical insights that help you make informed decisions about NoSQL databases. We have with us today two esteemed presenters, Suja and Theswini, who bring a wealth of expertise in database architecture, performance optimization, and data replication strategies. Now, as organizations scale, choosing the right NoSQL database can significantly impact performance, scalability, and data consistency. Today, we're going to compare DynamoDB and MongoDB across three key areas: performance characteristics, scalability models, and replication strategies. Now, although we say versus, this is not a competition. It's a deep technical analysis to help you understand which database is best suited for different workloads and use cases. This showdown of sorts aims to provide insights into their unique features, performance characteristics, and suitability for various applications rather than declaring a definitive winner. Now that we've set the stage for why NoSQL databases are so important in today's data landscape, let's take a closer look at how DynamoDB and MongoDB actually perform. Theshwini, with your extensive knowledge in this area, will you please walk us through benchmarking methodologies and explain how DynamoDB and MongoDB handle performances differently?
Sure, Adrian. So let's discuss performance. So as data complexity and volume have grown, so these relational databases often struggle to meet the demands for flexibility. So this has led to the adoption of NoSQL databases, which offer dynamic schemas. Among these, like DynamoDB and MongoDB have emerged as leading solutions. So, firstly, there's this Amazon DynamoDB, which is like a fully managed serverless key value, and it is also a document database that is designed for high performance at any scale. And next, there is MongoDB, which is an open source and also a document oriented database known for its flexibility and also its rich querying capabilities. So, to better understand how these databases perform under various conditions, right? So, let's explore some benchmarking methodologies and also delve into like specific performance traits of each one. So, accurately measuring database performance involves workload types and metrics. Simulating different operations such as read write and write heavy or any balanced workloads to reflect real world use cases, right? That's for workload types. And metrics is something where we are evaluating key performance indicators like latency and throughput, which is like response time for operations and also the number of operations per second. So this is the metrics that involves for like the benchmarking methodologies. So now let's briefly look at the performance characteristics for both DynamoDB and MongoDB. So DynamoDB is optimized for applications requiring consistent and single digit millisecond response times at any scale, right? So these key features include scalability, latency, and data model. So, firstly, talking about scalability in DynamoDB, it will automatically manage the data traffic across partitions. So, it will handle large scale workloads seamlessly. So latency is also designed for designed for low latency operation. That is, DynamoDB is designed for low latency, which is very ideal for real time applications. So coming to data model, it will support key value and document data structures, but it has like some limitations, which is like only one numeric type is supported, and also it lacks a few data type support. So this is about the data model for DynamoDB. So also let's look at the performance characteristics for MongoDB. So MongoDB has flexibility and a rich set of features with its performance aspects as well. It allows like dynamic schemas, enabling easy modifications as applications requirements keep evolving, right? In today's world, it is not like a static requirement that we have. So when it comes to MongoDB, it is very flexible with schema design, hence allowing our developers to alter the schema without having to change any of the data that is already available. So it uses the JSON formatting, wherein it's helpful for developers to change everything without having to touch any data that's readily available. And also advanced querying, it supports complex queries and indexings, so this can impact the performance based on use case, right? So it also has advanced querying capabilities. So whenever we have some environment in our applications which will need complex querying capabilities, I think MongoDB is the best fit. So let's talk about the supporting data types as well. In MongoDB, it offers like really wide range of data types, which includes, to name a few, it has like int, it has long, it has date, timestamp, geospatial, floating point, decimal, etc. So and so say it keeps growing, and hence it will provide a versatility in data modeling as well. So it has like huge types of data type available for MongoDB, Adrian.
Yeah, thanks, Deshwini. I think that was a really perceptive look at the performance specifics of both DynamoDB and MongoDB. Now we've got a better understanding of how DynamoDB prioritizes speed and scalability, while MongoDB offers a little more flexibility in its data model and querying capabilities. I think we're ready to take it to the next level by walking through a comparative analysis of these two powerful databases. Let's focus on the trade-offs between data consistency, scalability needs, and feature sets, which will ultimately help us get closer to choosing the right tool for the jobs that we have in mind.
Sure, Adrian. So, when talking about comparing DynamoDB and MongoDB, right? So we have to consider multiple aspects of it, but to curate a few, it's like the data consistency and the feature set. So primarily, we got to check this one. Data consistency in DynamoDB offers eventual consistency, right? So which can lead to unnoticed data losses. So this doesn't happen in MongoDB. That's hence it is like it's providing strong data consistency if we compare that way with DynamoDB. So we have to look at that one. And when it comes to scalability needs, DynamoDB is excels in the environment that requires scaling with minimal operational overhead, right? So feature set for MongoDB has like extensive querying capabilities. So it also has diverse data types, like I discussed in our last slide. So MongoDB is very great for complex data interactions, wherein DynamoDB is excellent, which requires scaling with minimal overhead. I think understanding these nuances will aid in selecting the appropriate database, I think, tailored with your specific application requirements.
Yes, well, thank you for that overview of the key differences between DynamoDB and MongoDB. Veshwini, I think clear, like you just mentioned, that we really do need to understand those nuances of data consistency and feature set because it's crucial for making the right database choice. So I think we can further illuminate our decision-making process by shifting our focus to another critical factor, scalability. So let's get ready to delve a little bit deeper into how DynamoDB and MongoDB handle those large-scale applications and high-traffic workloads that can make or break a business.
Sure. So, in our exploration of scalability with NoSQL databases, right? So, particularly focusing on DynamoDB and MongoDB today, like we have several aspects that emerge. So, mainly it is like hot partitions, capacity planning, and scaling, like we have been discussing on the last slides. So, before we delve into this one, we also want to know about horizontal and vertical scaling, which is also equally important to understand, because in vertical scaling, right, we are it is like enhancing the single server's capacity just by adding more and more resources, like adding CPU, RAM, like on and on, which has limitations due to its hardware constraints and also its potential cost increases. So it is not a good choose if we have to go between horizontal or vertical scaling. In horizontal scaling, it is about expanding the capacity by adding more servers or nodes to the system. So this will allow distribution of load and the data, right? So for both DynamoDB and MongoDB, it is designed with horizontal scaling in mind. So definitely these two outshine any other DBs for any other NoSQL databases. So let us jump for into discussing the hot partitions and capacity planning. So firstly, I'll talk about Amazon DynamoDB. In DynamoDB, automatically adjusts the throughput capacity in response to its actual traffic patterns, right? So it is ensuring the consistent performance. And if we have to understand about the capacity planning, uh, the application workload patterns is very much essential for setting appropriate read write capabilities. So we have to do a proper capacity planning which will optimize both the performance and the cost. And now we have something called hot partitions, which we have to look at while choosing or to our application while tailoring specific DBs to our needs. So in hot partitions is nothing but when uneven data distribution happens, right? This can lead to disproportionate amount of traffic that the partitions are receiving. So this will in turn cause performance bottlenecks. It is very much important to properly plan the partition key design in order to mitigate this issue. So that is about hot partitions that we had to discuss today with regards to Amazon DynamoDB. And next one, we want to discuss about the scalability for MongoDB as well. Here, one of the very important concept that I and Suja will be discussing more on this sharding concept, but I will give a brief on what is sharding in MongoDB. So this concept of sharding distributes data across multiple servers using a key called shard key. That is that will determine the data placement. So this key is helpful, or this is the key which will determine the data placement. And also its effective sharding enables horizontal scaling, and also it will balance the workloads. So this concept is like very beneficial in MongoDB. And also choosing the right shard key is vital for even the data distribution and query performance. So you also have to consider the frequency of access. Otherwise, choosing the right key will give you the efficient query performance, and also the data is evenly distributed without having to manually intervene, or you know like. And next I would want to discuss about replica sets. So they provide high availability by replicating the data across multiple nodes. So in sharded cluster, right, each shard is typically a replica set. So the data is replicated across all the nodes. And I think this is pretty much brief about scalability for MongoDB, which you'll be Suja will be discussing much in the next slides. And when determining the appropriate database for various scaling scenarios, it's essential to consider some distinct characteristics of Amazon DynamoDB and MongoDB. So it's mostly based on the workloads and querying performance. For DynamoDB, if you have to choose it, it's very ideal for fluctuating workloads. MongoDB is more suited for applications that require the complex querying capabilities. So DynamoDB is very helpful for fluctuating workloads, and also the applications that require automatic scaling with minimal operational overhead. So that's when DynamoDB is the best fit. And also when the applications need complex querying capabilities, I think MongoDB is the best fit. So especially when the workloads are more predictable but has complex querying capabilities. And it is more suited. And also the custom sharding strategies available in MongoDB, right, it makes it more beneficial for the applications to choose this one. I think understanding these scalability features will aid in selecting the appropriate database solution tailored to your specific applications. I think that's pretty much it, Adrian. Hope I will.
Yes, no, that was really helpful, Teshwini. I think you're on a roll. So thanks for that clear explanation of scalability differences between the two. I think it's fascinating how DynamoDB excels at automatically handling fluctuating workloads, while MongoDB gives you more control over your data distribution, especially for predictable workloads. Now that we have a solid grasp of both performance and scalability, let's turn our attention to a critical aspect of database management, replication strategies. To guide us through this topic, Suja will illustrate how DynamoDB and MongoDB handle replication, their trade-offs, and the best use cases for each approach. So Suja, the stage is yours. Take it away.
Thank you, dear. Hello, everyone. I welcome you all. I think we have got a fair idea on how does DynamoDB and MongoDB works. So let me continue further. Like as we know in distributed system, replication is essential for data availability, tolerance, and scalability. But as we said, not all replication mechanisms work the same way. In today's session, we'll focus on few key things like consistency models, DynamoDB replication, MongoDB replication, and comparative analysis of DynamoDB and MongoDB. In consistency models, we need to understand the cap theorem and the trade-offs of both the databases. And in DynamoDB replication, we would be seeing global tables, cross-region replication, and disaster recovery management, how it is done in DynamoDB. In MongoDB replication, we need to focus on replica sets, read preferences, and data synchronization. Also in replication tools and techniques, we would see like how modern tools including platforms like DBSync support this heterogeneous replication with real-time data change. And lastly, we'll do a comparative analysis, and based on the needs of the end customer, we can decide which DB to go for. So before we dive into DynamoDB and MongoDB replication strategies, let's quickly cover the foundations. For example, when we go to the consistency models, we usually follow CAP theorem while selecting a database. What does the CAP theorem states? CAP stands for consistency, availability, and partition tolerance. To make you understand better, let me give you an example. Imagine if you're running a ice cream parlor or maybe a lemonade stall and you want to make sure it works perfectly for your customers. There are three things you would care. First thing, consistency. You would want every customer gets the exact same ice cream flavor, no matter who is serving them, or no one gets a different flavor. So that is called consistency. When it comes, second thing, there is availability. You want your shop to be always open and ready to serve ice cream whenever someone walks up. There are no delays and no excuses. And third thing, you should have partition tolerance. What if something crazy happens? Like a big storm splits your stand into two separate locations. You can still keep serving ice cream without everything falling apart. So these are the key things which we have to focus on while adapting to the cap theorem. But there is a catch. In cap theorem, it says you cannot have all these three things working perfectly at the same time. For example, you can focus on two things at a time and third one might take a hit. Let's see how does this plays out. For example, case 1. In case 1, we'll focus on consistency and availability, and there is no partition tolerance. So what happen here is you make sure everything, every serving of ice cream is perfect and your stand is always open. But because of the storm which has hit your stall, you might face some downtime and there is no power backup, and you have to shut it down until you find a power source. Case 2, there is a consistency and partition tolerance, but there is no availability. For example, you keep the recipe perfect, you keep the flavor perfect, and even if the storm splits your stand, but some customers might not get served because one half has been stopped working and you have to manage with the other half. In the third scenario, we have availability plus partition tolerance, but there is no consistency. Here, your stand stays open no matter what, even during storm, but some customers might get a slightly different flavor because the two halves cannot sync up on the recipe. So in the same way, in the tech world, this applies to databases as well. Like the one storing info for apps or website, the storm here is like a network failure or maybe a server shutdown. So engineers have to decide what is most important for them. Here they want perfect data, that is called consistency, and always being online, that is called availability, or staying functional even during a split, that is partition tolerance. They cannot have all at the same time, so they have to choose based on their needs, which are the two key things they need to focus on. Now let's see what are the trade-offs we have in NoSQL databases. As we see, when we have few strengths, there will be few weaknesses as well. And based on the customer's needs, we need to decide which databases, which NoSQL databases we need to go for. See, each has its own strengths and weaknesses, and the best pick depends on the needs of the end customer. So let's see what are the strengths and trade-offs of DynamoDB. For example, in DynamoDB, we have availability and partition tolerance. DynamoDB is designed to keep running no matter what happens, because it is basically works on different time zones. Like there are different zones for the data servers. Even if one fails, you can switch to the other. There is scalability. It scales automatically. You don't have to manage servers or clusters. It's all done automatically. Third, being low maintenance. It is fully managed. You have to skip the hassle of patching, backups, or hardware tweaks. It's all set it and forget it deal. And there are trade-offs for DynamoDB as well, like consistency, flexibility. By default, DynamoDB leans towards eventual consistency. Data might not be identical across all the server because it will take some time to write on all the servers, even though it is minimal. But if coincidingly two people are accessing the same page at a time, it might sometime happens that they may get the same data visible without the real data being updated. And then there are query limitation. It is fast for simple lookups, but when there is a concept of complex queries like filtering or joining the data, it is impossible to do it without adding extra work. So there are few query limitations with DynamoDB. So if your app needs deep data analysis, you might need to go for some different system. And third drawback being, it's a vendor lock-in. You are tied to AWS. If you want to move to Google Cloud or your own server, then you may need to move out of DynamoDB. Now coming to MongoDB, what are its strengths and its trade-offs? Strengths being consistency options. MongoDB gives you complete control. It supports multi-document transaction with ACID properties like traditional databases, so you can ensure data stays perfect. Second being query power. It's a champ at complex queries. If you want to search, filter, or aggregate data, MongoDB's rich query language and flexible indexing lets you dig deep without breaking a sweat. Think of it as having a toolbox for any data job. And third, flexibility. The document model handles nested, messy data beautifully. If your app needs to changes, like adding new flavors to your ice cream, MongoDB adapts without a fuss. Plus, you are not locked into one cloud provider. You can install it locally or you can move to other server at any time. So there are few trade-offs with MongoDB as well. Basically, availability and scalability effort. MongoDB can scale and stay available, but it's not automatic. You have to set it up. And we already heard about sharding concept, where the data is getting split across the data servers, and replication has to be done by yourself. Or use MongoDB Atlas. That's their own tool, the managed version, which still requires more configuration than DynamoDB. Second thing being management overhead. Unless you are an Atlas, you are the mechanic for all their handling servers, updates, backups. Even with Atlas, you have to do few tweaks than DynamoDB's approach for simplicity and control. And lastly, we have performance variability. It's fast for complex queries, but latency can jump if your dataset grows huge or queries gets wild. DynamoDB's predictable speed edges it out for simple and high volume tasks. Now, coming back to the cap theorem perspective, if we go with the cap theorem perspective, DynamoDB picks availability and partition tolerance by default, whereas MongoDB leans towards consistency and partition tolerance. Now let's talk a little bit about how DynamoDB manages replication. So DynamoDB is built by Amazon to be super reliable and fast, and replication is a big part of that. Here's how it works. Multiple copies getting created automatically. When you save something in DynamoDB, like a new order, you don't just write it to one server. It automatically makes copies across the servers. Like usually it keeps 3 copies or sometimes two, and spreads them across different machines in the same region, like 3 nearby towns. This way, if one server crashes, then you have the backup of other servers. Second, leaders and followers. There is a concept where one server acts as a leader for each piece of data, and it's the main stand that takes your order and writes it down. The other copies the data, which is called as followers, and gets updated right after the write. The leader makes sure everything stays in sync, but it's quick about it. And third point, handing writes fast. When you add or change data, DynamoDB doesn't wait for all copies to agree before saying done. It writes to the leader and at least one follower. then tells you it's saved. The third copy catches up a tiny bit later. This speed is why DynamoDB is so snappy. It doesn't make you wait. And fourth thing, eventual consistency. By default, DynamoDB uses something called eventual consistency. For example, imagine if you are in one of the restaurants and there is a recipe and you wanted to modify it and you wanted to make some changes, but then the others takes a minute to get the memo. If a customer asks right away, they might get the old receipt from one stand and the new one from another. Eventually, all stands match up, but there's a brief window where they might differ. You can choose strong consistency instead, where all stands agree before serving, but it is slower. Fifth, surviving problems. If a storm cuts off one town, a server fails or a network splits, DynamoDB keeps going. It does not stop. The other copies pick it up with a little slack, so you can still get your data. This is why it's great staying available even during trouble. And lastly, we have the concept of regions and global tables. With DynamoDB, you have global tables. You can replicate data across different regions, like maybe one region is in US, Europe, or maybe another one in Asia. So each region has its own set of copies and they sync up over time. If one region goes down, another can serve customers. You just decide which regions to use and Amazon handles the rest. And there is no much mechanical work over there. You can set it up and accordingly the DynamoDB picks it up whenever there is a failure. So let's take a real life example. How does it happen? Say you're running an online store, a customer adds a shirt to the cart. That is what we called as a write to the DynamoDB. That is what it is writing whenever you add something to the cart. So it's saved to the later server and one follower right away. So the cart updates first. If another server hasn't caught up yet and customer refreshes their page, they might see a brief delay and it displays old cart. But it syncs up in milliseconds. Meanwhile, if a server dies, the other keeps the store running. That's DynamoDB replication, keeping things smooth. In short, DynamoDB replication is like having a team of stands that share the load, stay open no matter what, and mostly agree on the receipt. Just don't expect them to sync perfectly every second unless you tell them to slow down and check.
Wow, that was a very comprehensive look at Dynamo's DB replication strategy, Suja. Great examples to really help illustrate that point. It's impressive how DynamoDBC offers automatic cross-region replication with global tables and the flexibility to choose different consistency levels based on application needs. Now, let's change gears a little bit so that we get a well-rounded understanding of replication in the NoSQL world by exploring how MongoDB tackles this challenge. Can you walk us through how MongoDB's replication approach compares to what we've just learned about DynamoDB, Suja?
Sure, Adrian. Let's see if we see the MongoDB's replication approach. It's an open source NoSQL database and uses something called a replica sets to handle replication. Think of a replica set as a small team of Lemonade stand working together. Here's how it works. For example, there is a team where you have primary and secondaries. There's one primary stand. The boss takes all the orders, that is called writes, and updates the receipt. Customers only talk to the stands when they want to change something. And there are secondary stands, usually two or more. They copy everything from the primary and just does the serving. These are like backup stands keeping the notes. Second thing, copying the receipt, what we call it as data replication. When you write something like adding extra sugar to the receipt, the primary stand locks it in a special book called operation log. It's a step by step record of changes. The secondary stands, what it does is constantly check that operation logbook and copy those changes to their own notebook. This keeps everyone in sync, though it might take few seconds to update. Third thing, strong consistency by default. MongoDB likes everyone to agree. When you write to the primary, it makes sure the changes is solid before saying done. You can even tell to wait until most secondary copies it. That is called write concern in the terminology of MongoDB. So it's like double checking all strands have the new receipt before serving. This means you usually get the same answer no matter which stand you ask. That is called perfect consistency, what we have in MongoDB. Fourth one, we have handling trouble, or you can see it as failovers. If the primary stand goes down, say the storm knocks it out, and there is a server failure, the secondaries hold an election and they pick a new primary among themselves based on the most up to date server which is ready to act as a leader. It's quick, like the team choosing a new leader in a minute or two, and then it start updating other secondary servers. While this happens, you might lose service briefly, but there will be no but there will be no similar instances, like it will update to the secondary and the data stays safe. Fifth thing, you have to set it up. Unlike DynamoDB, where everything happens automatically, Amazon does everything there, but MongoDB puts you in charge. You decide how many stands or how many servers you want in your replica set. Usually, you can go with three or maybe with five. And where they are same building or different cities, you can run it yourself by using MongoDB Atlas to make it easier. And for the scaling reads, if you want faster service, you can tell customers to ask the secondary stands for read info, spreading the work. But if the secondaries are a bit behind, they might give slightly old answers unless you tweak the settings. In short, MongoDB replication is like a team of stands where one acts as the boss, the others follow its leads, and they regroup if the boss is out. You get solid data and flexibility, but you are the one keeping the team organized. Less automatic than DynamoDB, but more in your hands.
Hmm. Okay, so thanks for that informative overview of MongoDB's replication features, Suja. Besides making me hungry with all those examples, it's interesting to see how MongoDB's replica sets offer different preferences and right concern options for fine-grained control over consistency and latency. So let's expand our understanding of replication beyond the built-in capabilities of DynamoDB and MongoDB by examining how tools like DBSync can simplify and enhance data replication across diverse environments. So, Suja, if you walk us through some of those challenges and solutions in the area, we'd be most grateful.
Sure, Adrian. Let's explore some technical challenges and what could be the solutions which are already incorporated with our tool, which is DBSync. Uh, like first being the heterogeneous database replication. The challenge here is moving the data across different databases. For example, if you say you are moving from MongoDB to DynamoDB, or maybe from the traditional databases, whether it could be from MySQL to SQL Server, or maybe to the cloud databases like Snowflake. Here, usually we have a challenge of schema mapping because data types are not same across the all the different databases. Data type might change, their character precision might change. So in that way, we need to do the schema mapping and transformation tool like DBSync. It will help you align the data structure. It automatically converts your data type with respective to your current database and make it easier to move the data across the platforms. Second thing being the real-time data synchronization. There is a challenge keeping the data in sync across the distributed databases with with low latency. In DBSync tool, we have two concepts, one being the CDC, that is change data capture. So we have adapted this change data capture concept. What it does is whenever there is a change in source, it automatically make the changes to the target without any manual intervention or without any time based events. So it automatically detects if there is a change in the source and it directs to the target database. And second being event driven replication. For example, if you don't want to use CDC, you can keep a scheduler maybe every night or whenever there is a low activity on your servers. So you can use the scheduler tab of our DBSync and schedule the task where it moves the data from source to target with the command called source to DB incremental, which can be set with cron jobs or maybe time based as per the convenience. Third being the conflict resolution. That is one challenge what we have. So handling conflicts when data is written to multiple sources. Usually what happens is when there is a bad data, it gets written to the databases and it corrupts the databases. So custom conflict resolution logic has to be applied there. Time based writes has to be done, otherwise you will face a deadlock error there. Or maybe last write wins policies. These are few mechanisms through which you can get over these conflict resolutions. Last, data validation and monitoring. There is a challenge for and data integrity and validation during replication. So you have to set validation rules, you have to have a proper monitoring dashboards, consistent reports being fetched, maybe consistent emails or webhooks through which you can get the recent updates for each of your data runs, which we already incorporated in DBSync tool. So while DynamoDB and MongoDB have strong built-in replication features, tools like DBSync can further simplify replication, especially when dealing with multi-cloud or hybrid database environments.
Again, another insightful look at the challenges, the solutions, and heterogeneous data application replication, Suja. I think it's clear that tools like DBSync can really be valuable in managing complex replication scenarios, especially when we're dealing with different database types or multi-cloud environments. So let's pull it all together. together with a concise comparative analysis of DynamoDB and MongoDB's replication strategies by highlighting the key takeaways to give us a better understanding of which database might be the best suited for different replication needs.
Sure, Aaron. While comparing DynamoDB and MongoDB, there are few takeaways which we're gonna look at now. One being the replication type. In DynamoDB, you have global tables which is spread across multiple region and it is multi-active. In MongoDB, similarly, you have replica sets, which where you have the concept of primary database and then secondary database. And if primary fails, the secondary becomes the nearest updated database becomes the primary and transfer the data to other secondary databases. And when it comes to consistency, we have eventual or strong consistency with DynamoDB. Even with MongoDB, we have the concept of strong with primary and eventual across the secondaries. When it comes to failover mechanism, automatic across AWS region, it is done by AWS. And when it comes to MongoDB, it is done through replica sets. So reading scalability, if you go to DynamoDB, you have global read replicas, and in MongoDB, you read from secondaries. So best use case would be for DynamoDB, multiple region applications, low latency global apps. And for MongoDB, it could be read heavy workloads and flexible failovers. There is a concept like one shoe fits all, and we don't have it in a database. For there, you have to understand what are the customer needs and then decide. For example, if I want to take DynamoDB, then the companies like Netflix, Amazon, and Lyft prioritize speed, scalability, and tight AWS integration for their transactional and real-time systems. So that is why they would prefer DynamoDB. It's a go-to for workloads where predictable performance trumps the schema flexibility. For example, if you take on Amazon Prime days, you have a huge surge of customers and you cannot say how many servers would you need. So it has to be done automatically. That is the best use case when DynamoDB comes in picture and AWS handles it automatically to manage that surge of customers. Even the same case in Netflix, when there is a new release, maybe of a series or a movie, you have a huge customer surge on their platform, and that has to be handled efficiently, and that can be done by using DynamoDB. Similarly, if you look at the advantages of MongoDB, firms like eBay, Adobe, and UPS go for MongoDB where they need adaptability for diverse data, and they use complex queries and they deploy outside a single cloud provider. So it is favored for its developer friendly document model and versatility. So these are the key differentiates what we have for DynamoDB and MongoDB.
Thank you again, Suja. That was a really excellent comparative analysis, which is really helpful. It's nice to see the strengths of each database laid out so clearly side by side. And just like that, we've reached the end of our webinar, the NoSQL Showdown, DynamoDB versus MongoDB. I hope that all of you found this deep dive into performance, scalability, and replication strategies valuable. So let me just recap some of the key takeaways from all that excellent information. One, in regarding performance, DynamoDB excels in speed and scalability, while MongoDB offers more flexibility in its data modeling and querying capabilities. In the case of scalability, MongoDB automatically handles fluctuating workloads, while MongoDB provides more control over data distribution for predictable scenarios. For replication, DynamoDB offers global tables for multi-region active-active replication, while MongoDB uses replica sets for primary, secondary failover with strong consistency. Thus, tools like DBSync can certainly bridge that gap between different database types and simplify replication in hybrid environments. So ultimately, the best choice between DB and MongoDB depends on your specific needs and priorities, and we're here to help. So if you have any further questions or want to explore how DBSync can help optimize your data management strategy, go ahead and pop those questions in the chat right now for us to answer. And if you happen to think of some after the fact, as always seems to happen, please do not hesitate to reach out to us via email, as you can see on our screen there, or by phone. You can also visit our website at www.mydbsync.com to gain insight into all of the DBSync offers we have in this space. So now don't worry about writing our contact information down. You'll receive an email copy of this webinar, and then you'll just have this information right at your fingertips. So let's take a look at some of the questions from our audience before we officially wrap up. We got a few questions beforehand. Let's take a look. So the first one would be, how does MongoDB and DynamoDB handle complex querying, and how does that impact app development?
I'll take this,
Suja
Adir.
or okay,
Yeah. So, as I said earlier, MongoDB offers a rich and expressive query language as compared to DynamoDB. It allows developers to perform complex searches, filtering, aggregations directly within the database. This capability simplifies application development as much of the data processing can be handled at the database level. It reduces the need for additional application logic. In contrast to DynamoDB, it is optimized for straightforward key value access patterns and provides limited querying capabilities. Complex queries often require the use of additional AWS services such as Elastic MapReduce or Redshift to perform aggregations or analytics. This approach can introduce additional latency, complexity, and cost, as data must be transferred between services for processing. So, this is how we need to decide what are our needs. For MongoDB, you can work on query language, expressive query language. You can work with joins, and for DynamoDB, you have to be less dependent on auto scalability, and it is best case for whenever there is a server shutdown, it will automatically reassign it to some other server and makes the smoother running of the application. Thank you.
great. Now looks like we've got another question as well. So let's see. What are the costs to consider when choosing between MongoDB and DynamoDB concerning variable workloads? Teshwini, can you answer that for us?
Yeah, sure thing, Adrian. So the cost considerations, if we discuss about DynamoDB and MongoDB, so DynamoDB is based on throughput based pricing model, so where costs are directly tied to read write capacity that is provision. So this model can lead to variable expenses, especially with fluctuating workloads, right? You pay as you whatever capacity is provisioned for you, you pay for that regardless of the actual usage. So additionally, there are features like backup, restore, and on demand capacity, so that will incur you like extra charges in DynamoDB. So in MongoDB, the pricing model is fixed. That is based on the resource allocated, like the RAM, input, output, and the storage. This cost is predictable because it is fixed, and this may not be so much cost effective as you're paying for allocated resources, but it is very flexible. For it has got flexible scaling options, and the MongoDB will allow adjustments to resource allocation and also our workload demand changes. So MongoDB works based on fixed pricing model for whatever the resources is allocated. And as I mentioned, DynamoDB is with like whatever read write capacity is provision, it would be based on that one and not like how much usage, regardless of whatever we use. So this is the pricing model for Dynamo and MongoDB.
Great. Now I see we have another question from Balaji. Can we change the execution pattern in DynamoDB versus MongoDB? Who wants to take that one?
Uh, I can take that one. So, like
Great.
in DynamoDB, it is it has structured approach, right? So it has like predictable performance patterns in DynamoDB. So in DynamoDB, it's more of a key value and document data model. It has rigid schema design, right? So each item it is limited to 400 KB in size. So, but the data types supported are less diverse compared to MongoDB, but it has like predictable performance patterns. So however, like DynamoDB will require like additional effort to manage schema changes and adapt to the evolving data change needs. So over that, like MongoDB is much advantageous for applications that keep evolving, the data keep evolving. So I think
Two.
developers use B JSON format, right? In so it allows for dynamic schemas. So developers can modify the structure for documents without affecting the existing data at all. So that way, MongoDB will utilize, the document-oriented data model, and I think it is much advantageous.
Great. So I'm seeing, I know we're running on time. I've got one last question. Let's just see if we can quickly address that before we go. Um, let's see. So how do MongoDB and DynamoDB differ in terms of data modeling and schema flexibility, and how does this impact performance?
I think we pretty much covered this in our uh, slides, and also, I mean, last question as well. Like I mentioned, it is based, both are based on like document or oriented model, but depending on how dynamic it is, so MongoDB will enable that flexibility. So it keeps adapting to evolving data requirements, where DynamoDB is very much structured. Like I said, it has like fixed schema, and the schema design is more rigid. So it might be a bit difficult here to adapt to the evolving changes, but MongoDB is best and advantageous for application with those evolving data requirements. I think we pretty much discussed all of this in the last question as well.
Yeah, I think it's helpful. Sometimes we have to, kind of refresh our memories on things or just make sure we're understanding them in context. So thanks for re-illustrating that for us so that we're clear. So I think with that, we conclude our session today. Thank you so much for those questions. Very illuminating exchange. And thanks so much for your expert information, Suja and Theshwini. You filled us with tons of information in just a short amount of time. I also want to send a special thank you to all of our attendees for joining our webinar. We really appreciate your time and engagement. And we certainly hope to see you next time for another one of our sessions. But until then, have a wonderful day.
Thank you.
Thank you.